The statement of Thevenin's theorem. Anyone? Give me the statement of Thevenin's theorem.
Any two-terminal linear bilateral network
Okay.
can be replaced by an equivalent circuit consisting of equivalent source.
1 second. Right. Any two-terminal linear
Linear bilateral network
bilateral network.
can be replaced by an
Bilateral network. So everyone know about linear and bilateral networks. What we discussed in earlier sessions for superposition with Thevenin's theorem. Right. Two-terminal linear bilateral network
can be replaced by an equivalent circuit
can be replaced by an equivalent circuit
consisting of an equivalent source.
consisting of
Equivalent source
equivalent source.
VTH in series with resistance.
Here it is equivalent current source. In Thevenin's it should be equivalent voltage source. Here it is equivalent current source. Okay. So that value should be, we can call it as a IN because it is under Norton's. So therefore the current is called as Norton's current. Okay. And at the same time, it should be containing equivalent source.
VTH in series with resistance.
So there in Thevenin's, it should be VTH that should be in series with resistance because we know that the voltage sources, what we discussed in earlier under energy sources topic, for voltage source, independent voltage source, always the source having series resistance. Okay, that's why in Thevenin's equivalent circuit also equivalent voltage source in series with the resistance. But whereas coming to your Norton's theorem, here in the place of voltage source we are taking current source. So therefore for current source, how the resistance will be getting connected? In parallel.
Parallel.
Right, very good. Current source in parallel with resistance, that is equivalent resistance. That resistance is called as Norton's resistance, and this is also we can sometimes call it as a Thevenin's resistance also. Why it is called Thevenin's resistance I will inform later, but now you have to remember that it will also called as Norton's resistance. Right, where Rn is your Norton's resistance and In is your Norton's current. So shall I draw the equivalent circuit? So this is your current source, equivalent current source, which is in parallel with the resistance. So this is your IN and this is your Rn across the load terminals. These are your load terminals. If it is a resistance, the load, that should be RL. If anyone asking you the amount of current which is passing through RL, nothing but IL. So how can we calculate IL? Total current is IN. Okay, the total current given in the circuit is from current source, that is Norton's current IN, and here we are having two parallel branch resistances. Now what they are asking, what is the current which is passing through one branch out of given two parallel connected branches? So shall we apply current division rule? Opposite branch resistance, what is current division rule?
Opposite branch resistance by total.
Right. So here opposite branch resistance means for this we need to calculate. So it's opposite in the sense it should be RL by total resistance. RL plus RL multiplied with total current, nothing but your Norton's current. This is the formula to calculate the load current. that is current which is passing through your load resistor. Now, in order to calculate this load current, we need to calculate this RN, RL, and IN. Okay. So now the procedure to calculate IN. Note down. Procedure to calculate IN. We know the procedure to calculate VTH and the procedure to calculate RTH, right? In the similar fashion, the procedure to calculate IN. So note down the first point. Short circuit, make the short circuit your load terminals. And the second point, find out the current which is passing through that short circuit. Passing through that short circuit path. So that's why, shall I call that current as a short circuit current? And which is also nothing but your Norton's current. Because we are calculating the current which is passing through that short circuited path. So that's why that current we can also treat it as ISC. So here IN or ISC. Whereas in Thevenin's theorem it should be VTH or VOC. That is open circuit voltage. Here in the place of voltage, here there is a current. So current in the sense we need to take this short circuit. Understand? Now the procedure for RTH. Understand how to calculate your IN value? We will do numericals, then it should be easy to understand. So procedure for RTH is same as your Thevenin's theorem. That's why we are calling that as either Norton's resistance or Thevenin's resistance. So what is the steps to calculate RTH in Thevenin's theorem? Tell me. Steps to
Should
calculate.
remove or open the load resistance.
Right. Open load terminals. Good. Next.
Make voltage source into short circuit.
Right. Nothing but replace voltage source and the current sources with their internal resistances. Nothing but voltage source doing short circuit and current source making as an open circuit. And our third step, what is the third step? Third step to calculate the resistance. What is the third step?
Find the resultant resistance.
Find the resultant resistance present across load terminals. Done the procedure. Here only the difference between Thevenin's and Norton's was that there it should be containing voltage source in series with resistance. Here the source transformation, simply that voltage source and series resistance will be converted into current source in parallel resistance. Okay. So for that, how to calculate this current source IN means we need to short circuit the load terminals and find the current which is passing through the short circuit path. How to calculate RL means that should be same procedure as your RTH. We can apply the same procedure and the value whatever we obtained, we need to substitute in RL place. Whereas RL is whatever they mention in the problem, to which resistance the amount of current is passing through that. Whatever they're asking, find out the current which is passing through the given resistance, that will be by default your load resistor. Clear the theoretical part. So shall we go for numerical? Or having any doubts? Shall we go for numericals?
Yes, sir.
Yes, sir, let's do exam.
Yeah, okay. Noted all of you? So shall I erase?
Yes, sir.
No. Yeah. Right. Now write down one problem on Norton's theorem. Find the amount of current which is passing through. Find the amount of current which is passing through. Find the amount of current which is passing through 160 ohm resistor. Find the amount of current passing through 160 ohm resistor for the circuit shown below. For the circuit shown below by using Norton's theorem. By using Norton's theorem. The same problem what we did in superposition and Thevenin's theorem. Now we will check with the procedure of Norton's theorem whether we are getting same answer or different. Tell me the solution. What is the first step? We need to draw immediately the equivalent circuit of Norton's theorem. RL, RN, IN, and what they are asking, the current which is passing through 160. Tell me, what is the next step? What is the given data?
RL is equal to 160.
Very good. RL is equals to 160. They are given in the problem. So immediately we need to substitute in the equivalent circuit. Now what they are asking, current passing through 160. So what is the formula to calculate that? IL simply. So IL is equals to formula total current
RN by
RN by RN plus
RL.
RL. Right. So now we know RL in this formula, but we don't know RN and IL. So as per our procedure of Norton's theorem, we can calculate IN and RN. So how to calculate IN? What is the step 1 for IN?
Make the load terminal as short circuit.
That here load terminals are here the load resistance is which one is load?
160.
Right. So that means we need to make that 160 as a short circuit. Done. So now it should be 20, another 20. Now what they are asking, the second step is First step done, short circuited the load terminals.
Find the current passing through the short circuit path.
Right, right. That means this is the one current which is passing through the short circuit path. That is IN or ISC. So see here the amount of current passing through this loop from this source like this, correct? So again from this source at this junction point. Now shall I call this as for I1, this as I2?
Yes, sir.
So now what about ISC value?
I1 plus I2.
Very good. Your KCL simply. So here
Yes,
I1
sir.
in the sense V by R. What is V by R? 100 by for this loop. 20
100 by 20
plus I2.
plus 70 by 20.
Very good. 70 by
170 by 20.
total 170 by
8.5.
20. How much it should be?
8.5, sir.
Very good. 8.5 amperes. Now what should we do? Immediately we need to substitute your IN value. 8.5 amperes. Now our next step is to calculate RTH or RN. Both are same. So now what is the procedure to calculate RTH? The same, whatever you did, the same you need to rewrite here. Whatever we did yesterday, the same steps.
Yes, sir.
So the first step is the load resistance will be getting open and the sources are replaced with their internal resistances. Here there is no internal resistance given, that's why the given voltage sources are converted into short circuits. 20, 20. Value of resistance in between these 2 points. So RTH or RN is equals to 20 parallel with 20,
10 ohms.
10 ohms. So therefore your RN is 10 ohms. So now by substituting IL, nothing but 160 equal to your IN 8.5 into RN 10 by 10 plus 160. How much?
1 by 2, sir.
Right. So now it should be getting verified.
Yes,
Check
sir.
the solution of our previous problem, superposition theorem. For the same values, what we obtained, the current passing through 160 was 0.5 amperes. Now we did the same with the procedure of Norton's theorem. Also, we get the same answer. Now it should be clear for all of you.
Yes, sir.
Right, right, very good. So now all of you are confident to do the problems on Norton's theorem with this procedure. The
Yes, sir.
step
Sir,
one.
we will do one more, sir. We'll get.
Yeah, sure, we can do. Then what we did in yesterday's session, will anyone tell me that problem? We will do that for Norton's also. Now everyone complete this. Later we will do one more. If all of you completed this numerical, then we will move on to the next problem. So that I will erase the complete screen. Inform me once all of you written completely this numerical, the solution of a given problem. Meanwhile, remaining students try to do the another numerical what we did in Thevenin's theorem yesterday. That is a 3, 4, 5, 6 ohms resistances across 5 volts battery. You just start your numerical. Once everyone done, I will explain in the whiteboard. So all of you noted? Anyone still noting?
Done, sir. It's over.
Yeah. Okay. Durga Rao, roll number 1. Durga Rao, Devi Priya,
Yes, sir.
done, noted.
Yes, sir. Done, sir.
Okay. Avinash, Durgesh.
Yes, sir. Noted, sir.
Okay, right. Very good. Durga Rao, Durga Rao. Okay. Shravan, 17. Shravan. Chiranjeevi, noted. Okay, okay. Harsha,
Completed, sir.
Nikhil, Nikhil Raj, Srinivas Verma.
Completed, sir.
Right, good. Vamshi, number 7. Vamsi, Vasavi,
Done, sir.
good, good. Koteshwar Rao, Koteshwar Reddy.
Yeah, sir. Completed.
Okay, fine. Think Durgesh. Okay,
Sir.
presented Durgesh.
Yes, sir.
Done, completed. Sorry, not Durgesh.
Completed, sir.
Durga Rao, Durga Rao. Sorry, Durga Rao, number 1. Noted. Just I want to check.
Yes, sir.
Hukesh, number 18. Hukesh, are you there? Shravan Naik. Hukesh, are you able to listen?
Good afternoon, sir.
Yeah, good afternoon. Noted the problem?
Yes, sir.
Okay, fine. Vamshi, I am not getting for Vamshi. Vamshi, you need to get back. I will wait for 5 more minutes. If you are unable to get that, I will remove you from the session. Okay, we will move on to next topic. Note down. By using Norton's theorem, for the circuit shown in below figure, find the amount of current which is passing through 6 ohms resistance, by using Norton's theorem. you need to find the amount of current which is passing through 6 ohms resistance. So what is the first step? We need to draw the equivalent circuit, Norton's equivalent. IN for RN and RL, right? Then we need to find out for which branch current we need to find out of these two. Respond. Don't write anyone, just try to focus on the screen. Later I will give time to note it down.
RL, sir, RL.
So it should
I
be
will.
RL. That is, this is your IL. So what is the formula to calculate that IL?
RN by RL plus RN into IN.
IN. Right, very good. So here, what is the given data from problem?
RL is equal to 6.
RL equal to
6 ohms.
6 ohms. Good. So immediately we need to substitute here, and we need to find out the value of Norton's current. So what is the first step we need to do?
Make the load resistance into short circuit.
So your load resistance here in the given circuit is 6 ohms. So 6 ohms is getting short circuited. So now how to solve this circuit 3, 4, 5. And your second step is you need to calculate the amount of current which is passing through this short circuit path. That is simply your IN. So how to calculate that current? In order to calculate that, see here 4 and 5 are in parallel connection. The resultant is in series with 3. So shall we apply the current division? So when we can apply current division, if we know the total current in the circuit, then only we can apply. So where is total current in this circuit from the source? Here is your total current. All right. So first calculate total current. That is IT equals to total voltage by total resistance, nothing but equivalent resistance. So what is equivalent resistance here? So what is the equivalent resistance here? Leave. What is the equivalent resistance here? Calculate 4 parallel with 5, right? That should be in series with 3. What
47 by 9.
47 by 9, sir.
is equivalent resistance?
Yes, sir.
Yes, sir.
Okay, 47 by 9 or 8?
9.
9.
9, sir, 9.
Okay, then substitute in total current.
45 by 47.
45 by 47. Total voltage is 5. So 5 by right, all of you getting the same?
Yes, sir.
Right. So next, what should we need to do? The next step?
ISL.
Your RTH. ISC already we calculated. Your RN or RTH. So what is the procedure to calculate RTH? What is the procedure? Quick. What is the procedure to calculate RTH?
Open the load test.
Okay, open the load terminals, opened,
Make the voltage source into a short circuit.
voltage source into short circuit. So here you are having 3, 4 and 5. Here you need to calculate RTH. So RTH or Rn is equals to 5, 3 are in parallel. 3 into 5 by 3 plus 5. That resultant is in series with 4. How much?
47 by 8.
47 by 8.
Yes, sir.
Correct, all of you got the same. So now
Yes, sir.
substitute this Rn and In values. Okay. Here we did not calculated In, right? Sorry. IT
Yes, sir.
calculated, right? Very good. IT calculated, but we are not calculated ISC or IN. That is good. So your ISC or IN should be is nothing but simply the current division rule, opposite branch. What is opposite branch here? 5 by opposite to this branch. 5 by 5 plus 4. Multiplied with the total current, how much? 45 into 45
45
by
by 47.
47. Then how much we will get? So 5 by 9, 9,
25 by 47.
5 by 47 amperes. Right, good. So now we will indicate in the equivalent circuit. So 25 by 47 amperes. Here Rn value 47 by 8 ohms. So by substituting IL, nothing but current passing through 6 ohms equal to your Rn. Rn value 47 by 8 by 47 by 8 plus 6 multiplied with 25 by 47. How much?
47. Yes, sir. We got, sir, 5 by 19.
5 by 90.
5 by 19.
In amperes.
Same answer.
Yes, sir.
Good. Very good. Now it should be clearly understood how to solve by using Norton's theorem. Only the thing is here you need to remember the procedure to solve the given numerical. Okay. For Thevenin's we need to go with VTH. For Norton's we need to go with IN. Norton's current where it is a Thevenin's voltage. The rest of the procedure should be remains the same. The Thevenin's resistance and the Norton's resistance both will be remains same. Okay. Understood by all of you?
Yes, sir.
Yes, sir. All of you note down the solution. And here I want to give you one information that whatever we did this problem now, that is a 5 volts, 3 ohms, 4 ohms, 5 ohms, 6 ohms, this problem, your seniors written in last month in JNTUH semester examination. How much marks they are given for this problem? Can anyone? The same problem. This is your previous paper problem. They given this for, can anyone imagine for how many marks they given this problem? Just imagine for how many marks you are thinking of?
5.
Good. But the given marks are 9 marks for JNTU. Okay, that means why I am telling means no need to think difficulty. Okay, so just you need to move on as per the syllabus, right? Then we will get good marks. Is there any difficulty to solve this numerical to obtain the 9 marks out of 9? Any difficulty to solve this problem?
For 9 marks, it is okay, sir.
Yeah. No, my question was that is there any difficulty to solve this problem?
No, sir. No, sir.
No, right? So when we should said no, when we have the confidence to do this problem. Okay. So that's why keep practice whatever the models we are discussing in the class notes. Okay. Right. So shall we move on to the next topic?
Yes, sir.
All right. Here I'm erasing. So our last topic, keep the side heading as transient response of series RL circuit with DC excitation. Very important. We have two derivations for series RL and for series RC. Series RL one derivation, series RC one derivation. That's it. Only two derivations. If you are perfect in your nothing to worry about perfection in your integration, so that it should be, so that it will be very simple. Simple integrations you need to remember. That is integral 1 by x, right? What is the integral 1 by x? Integral 1 by x dx.
Log.
Log? Good, tell me.
X.
Right, log x, right? That is a natural logarithm, ln x. We can call it as an ln x, right? Under base of e, not 10. Okay, if it is a 10, we can call it as a log. If it is a base e, that should be the natural logarithm ln. Right, and like that. Similarly, if there is any integration for a constant, that is integral k dx. Integral k, right,
KX.
right. Very good, very good. These are the simple integration formulas you need to remember to do this derivation. Like that, somewhere you may get the differentiation in the later units. Now you need to remember these two formulas. Okay, so we will go for the derivation. So first we need to draw the circuit. See what is the name of the circuit given. What is the name of the circuit?
Series RL circuit.
Good, very good. It is an RL circuit. Okay, fine. But how these R and L connected? Series connected. So we know the symbols of R. R, right? And what is the symbol of L? L. R, L, right? Now these two are connected in series combination. So that means like this. Okay, these two are connected in series combination. Now some amount of current is passing through it. Now here the question is what they mentioned, the transient response. So transient response in the sense here we need to have one switch. Okay, this is your transient conditions. This is your V, that is a V of t with respect to time, how whatever you are changing that. And this is the directional giving that your current I of t, right? So now the transient response of, that is a t, transient response of series RL circuit with a DC excitation. Clear? The title is suitable now for this circuit. Now our intention was that what does it mean by the transient state and what does it mean by the steady state. Simply once you can have a knowledge on the transient state, then it should be easy to understand the steady state. See, for every system what we are having, the initial state and final state, right? So in between that initial state and the final state, how the parameters are going to differ, right, with these new conditions in between initial and the final state. That is the parameters in the sense your I of t and V of t, your current and voltages, how can they are going to adjust it for these new conditions imposed by the given voltage source. So here the voltage drop which is presented across here, these two are connected in series, means there existing some voltage drops. So shall I call that as VR and VL, that is a voltage drop which is presented across inductor as VL, and the voltage drop presented across R is VR, right? So the transient period in the sense between initial state and the final state, how the current and voltage parameters are going to adjust with the new condition imposed by the voltage source. With the new condition imposed by the voltage source in the sense, what does it mean by? So all of you note it down once. The period which is in between the initial state and final state, the initial state and final state, the parameters of current and voltage, the parameters of current and voltage adjusted to new conditions, parameters of current and voltage adjusted to new conditions which are imposed by the voltage source, which are imposed by the voltage source.
Sir, could you please repeat the one second, sir?
Yeah, the period in between, the period in between the period in between the initial state and the final state, initial state and final state, the parameters of current and voltage, the parameters of current and voltage adjust to new conditions, adjust to the new conditions, adjust to the new conditions which are imposed by new conditions which are imposed by the voltage source, which are imposed by the voltage source. Full stop. This is called the transient period. That period is called transient period. When things are going to change, when the things are going to change. Noted all of you?
Yes, sir.
1 second now, I'm getting one call. Okay, right. So where we stopped, all of you noted the definition? The
Yes, sir.
transient period, right? So now here simply in order to understand the definition, you know the significance of your inductor, right? What is the property of inductor? It does not allow sudden changes of, just you have to get back and check what I mentioned, the statement of inductor, the property of inductor, which does not allow sudden changes of
Current.
current. Very good, very good. That means, let us think, if the time period where if t equal to 0 minus, let us take t equal to 0 minus, that means just before the switch is getting closed. Okay, just before the switch is getting closed. So during that time, how the amount of current which is passing through this RL circuit, it should be 0, right? Since switch is not closed till. But at t equal to 0, what should going to happen? The switch is getting closed now, right? So inductor, is it allow the sudden change of current? Inductance,
No, sir.
no, right? Very good. Similarly, after particular time period, that is t equal to 0 plus. So in between these two conditions, how it should be going to behave, the amount of current and voltage. Okay, that is your transient period. Now we need to analyze the variation of this current, okay, how it should be going to behave during this transient period. We need to identify the equation for I of t. Okay, understand? All right. So shall we need to go for the derivation? Shall we apply KVL or KCL here? Because this is a loop, right? So which Kirchhoff law we can apply? Out of those two laws, which one we can apply? Tell me, KVL or KCL?
Sir, Kirchhoff loop law, sir. The algebraic sum of the.
All right, Kirchhoff loop rule, right? Nothing but Kirchhoff voltage law. Because here there is no junction point, there is no division of current. So there is no incoming and outgoing currents. There is only one current, that is I of t. Our intention is to calculate this I of t, right? So now by applying your Kirchhoff voltage law for this given circuit, so what is the equation? Tell me the equation now. Where the arrow mark is entering? What is
Negative,
the,
sir.
right? So minus V, right? Nothing but V of t. Here I'm simply writing is minus V. Next, plus voltage present across resistor, voltage drop across resistor, plus what is the voltage drop presented across inductor?
VL.
VL. Very good. Is there any another component? No, right?
No, sir.
So
Is equal to 0.
algebraic is 0. Now it should be V equals to, just I am rewriting, V equal
V is
to,
equal to VR.
so what is the formula for VR? I into R. And what is the formula for VL? Voltage present across inductor formula. Check fast. L into di by dt, right? You need to practice the VA relationships of RLC parameters. Okay. We discussed that while I am explaining the inductor. Similarly, while I am explaining the capacitor, I given the formulas for current passing through capacitor and voltage present across capacitor. Similarly, the current passing through inductor and voltage presented across inductor. Next. So now divide this equation 1 with capital R. Now from up to this, your electrical, from the next step onwards, so purely your mathematical, so you need to apply. Okay. So now you guys have to give this derivation by dividing with the capital R, by dividing equation 1 with capital R. What we will get? Tell me now. Don't write anyone, I will give the time. So just to focus on this.
V by R
Right, V by R, that equals to
is equal to
I,
plus L by R
right, L by
di
R
by dt.
di by dt. Very good. So L by R into dI by dt. Now shall I write like this? V by R minus I equals to L by R dI by dt. Now just I am taking both LHS side and RHS side in a reciprocal. Nothing but cross multiplication. So 1 by R minus I, that equals to R by L dt by di. Right? So up to this, okay for everyone? Understand?
Yep.
Right. Now again you need to do the cross multiplication. 1 by V by R minus I into di, that equals to R by L into dt. This di will be cross multiplied. Okay. Now the left hand side it should be I and di, right? On right hand side R L both are constants. This fraction is constant, and there is a dt. So now shall we apply the integration on both sides? Apply integration on both sides and tell me now. Because R by L is constant, that's why I written outside. Now see, this is the entire over x. Let us treat that. That is 1 by k minus x into dx. So what is the integration now? Ln of v by r minus I. For this x, what is the multiplication factor having polarity of -1? So that minus I written here. Correct? If I am wrong, you need to make a correction, because you people are strong in mathematics rather than myself. Correct or not? Integral 1 by, this is v by r is a constant as k by x dx, like that I treated. Okay, that equals to r by l into what is integral dt?
T.
T, right? T plus, this is a definite integration or indefinite integration?
Indefinite.
Right, so that shall we write the constant, integration constant k. Now how to find this k value? In the indefinite integration, how to find the k value? By taking initial conditions, right? MPC, just you finished. So by taking initial conditions in the sense I of t equal to 0 and t equal to 0. So substitute that and you will get k value in above expression. That is in second equation. Let us take some equation number for understanding. So now by substituting I of t 0, that means your I value 0 minus ln of v by r, that equals to t value 0, that means this expression 0 k, right? Now substitute your third equation in equation number 2, 3 in equation number 2. So minus ln, tell me, v by r minus I, that equals to r
Log
by
V.
l
R by L into T minus ln of V by R.
v by r, right? Now what is our intention? To calculate I of t, right? So that means we need to remove the logarithm on both sides. So how can I remove? Right, shall I write like this? Check once. Just I'm taking this ln of v by r minus 1 to right hand side and r by l into left hand side, like that. This is I, right? Now shall we apply ln a minus ln b? What is the formula? Ln a minus ln b?
Ln A by B.
A by B.
Very good. Ln of v by r minus I by v by r. Now shall I remove the logarithm? by V by R that equal to e power minus R by L into T by keeping this base of exponential to the right hand side. Now, so from this, will you just simplify and calculate I of t? That is V by R minus I equal to V by R e power minus R by L into T. So from this I of t is equals to, what is the final expression? If you keep V by R on the right hand side, taking V by R as a common, shall I write 1 minus this is your final expression. So what is the final expression? I of t is equals to V by R into 1 minus e power minus, sorry, e power minus R by L into T. This is your I of t. Understand the derivation? So up to this, you need to apply your electrical knowledge, that is your KVL for the given circuit. There is only one loop is presented, so that's why here I'm applied as a KVL minus V, where the current is entering at the negative polarity, plus voltage drop VR plus voltage drop across inductor VL. So by this, now I'm dividing the entire equation 1 with respect to capital R, and after doing the simplification and rewriting the equations, here I applied the integration on both sides. There itself I got the value of current I of t after a few refinements. Then understand by everyone? Having any difficulty to solve this derivation?
No, sir.
No, sir.
Take 2 minutes of time and note it down neatly in your fair notes. After noted, inform me.
Complete, sir.
Completed all of you? So shall we move on to next topic? Shall I erase the screen?
Sir.
All right, okay. Manoj, Vasavi, completed?
Yes,
sir.
sir.
Right, okay. Then keep the heading as the last topic in the first unit. So can anyone tell me that last topic in first unit? Just I posted in your group the syllabus of JNTUH Hyderabad, your unit 1.
Sir, I'll
Sir, now it is RC circuit, sir.
Right, very good, excellent. See, in the syllabus, what they mentioned, time domain analysis, right? If you are having any confusion, you can keep the side heading as time domain or transient response. Both are same, okay? Both are with respect to time. So here I am writing the transient response of series RC circuit transient response of series RC circuit with DC excitation. If anyone having any confusion in the place of transient, you can make it as a time domain analysis. Both are same. Okay, so shall we draw the circuit of RC? How these resistor and inductor connected? How these two are connected RC? Series or parallel?
Series.
Series, right? RC. So because here we need to do the time domain analysis, they're existing the switch with respect to time. Total voltage V of t, current I of t, VR, and the voltage drop which is presented across the capacitor Vc. Now quickly tell me, by applying KVL, the same procedure but a little bit of a different derivation, just while doing your mathematics. Just tell me, by applying KVL, what is the equation now? Don't write all of you, just to keep focus on screen and tell me. I will give the time after end of the derivation. What is KVL equation?
Minus V plus
Minus V plus
VR plus
VR plus
VC is equal to 0.
very good. That means V equals
V is equal to VC plus VR.
right. So shall I write like this? IR plus VC. See here, for this derivation, here in the place of inductor, what we are having? Capacitor, right? So
Capacitor.
what is the property of capacitor? It does not allow sudden changes of. It does not allow the sudden changes of. Get back to your capacitor topic.
Voltage
Voltage.
does not allow
Voltage.
Very good. Whereas inductor, it does not allow sudden changes of
current.
Current.
So that's why in previous derivation, their existing inductor we are calculated as an I of t. Now this is capacitor. For this we need to calculate the capacitor voltage, right? Because it does not allow sudden changes of voltage, so that behavior we need to note it down. That means at the conclusion of this derivation, what is in the left hand side? It should be Vc of t, right? Clear, understand? So Vc is the parameter we need to identify with the known parameters. So that's why don't replace Vc with any of the formulas. You need to eliminate I value. So what is the current? Current is the same. I of t is the same for passing through R and passing through C, because this is a series circuit. Current passing through both elements remains the same, correct? So shall I replace?
Yes, sir.
Shall I replace with this I with your capacitance current? What is the formula to calculate current passing through capacitor? C into
Integration of
dVc by
dV by
dt,
dt.
right? Into R. R under the constant, I am writing in front side, plus Vc, that equal to your V. Now, just from this you need to apply your mathematics. Just refinements of the equations. So V minus Vc equal to Rc into dVc by dt. And how can we turn up this? Right, Vc, that is dVc by V minus Vc, that equals to reciprocal 1 by Rc, which is multiplied with dt. Shall I write like this? The cross multiplications, V minus Vc on the right hand side and Rc dt left hand side. Just I replaced that. Done up to this, having any doubts? Just to focus for 10 minutes, we will finish out. So up to this, is there any doubts?
No, sir.
So
no,
take
sir.
equation 2. Now apply integration on both sides. For equation 2. So therefore what should it will be? 1 by V minus Vc, dVc equal to 1 by Rc is a constant. So integral dt. Now what is the integration now? Same formula.
Minus non.
Right.
Minus non.
V minus Vc.
C
That
minus
equals to, here 1 by Rc is a constant. Integral dt.
Into t.
Right, into t. So shall I write directly t by Rc? plus this is indefinite integral, that is the integration constant. So how to calculate value of k? By applying initial conditions. What are the initial conditions at t equal to 0? Your VC value will be 0. So substitute your initial conditions and we will obtain ln v minus 0. That is ln v equal to t is 0. So this expression will become 0 and this is your k. Now take this as our equation 3 and equation 4. Substitute 4 in 3. So what we will get now? 4 in 3 minus ln of v minus
minus ln v minus vc is equal to t by rc minus ln v.
ln. Right. Now just to take the refinements to calculate VC. Okay. So how should we? Right. We will keep both logarithms in one place.
ln of v minus vc minus ln v is equals to minus t by rc.
Right. Very good. Now what? How can I replace it? ln A minus ln B. ln A by B. Minus B RC. So shall I remove logarithm? So from this, your VC equal to V minus V into e power minus t by RC. Therefore, if you take a common, done, completed. So no one don't write. If anyone already started written, then before that you need to keep one small side heading, that is after your transient or time domain analysis of series RL circuit derivation. After I of t, after making the box of I of t formula, that is v by r into 1 minus e power minus r by l into t, right? What we got. After that, you need to write one single statement by keeping the side heading as time constant. We are represented by capital tau for RL circuit. Okay, note down quickly the definition of that. It is defined as the ratio of it is defined as the ratio of it is defined as the ratio of inductance to resistance of given RL circuit. Ratio of inductance to resistance of given RL circuit. Understand? It is defined as the ratio of inductance to resistance of given RL circuit. Now, what is the formula for tau? Tau equals to, what is the formula now in mathematical form? Ratio of tell me fast. How can we represent in mathematical form? Ratio of, shall anyone give the definition? What you just written? Anyone quickly?
The
What is
ratio of inductance to resistance.
inductance
L
to
by R.
resistance? Right, L by R. Very good. L by R. So the units are seconds because this is a time constant. Okay. So now what is the equation we obtained at the end of RL circuit derivation? I of t equal to, can anyone tell me?
E by R 1 minus E to
V
the
by
power of
R into
RC
1
r
minus
into 1 minus e power minus r by l into t.
t. So now shall I replace that R by L with your 1 by tau. So I of t
Yes, sir.
equal to V by R into 1 minus
One
by tau.
by tau.
T by tau.
So in some of the textbooks, they will mention like this and they will draw the curve. You have one experiment in your laboratory to draw the exponential curve, okay, how it should be coming with the values of tau, okay. You will get that curve in your laboratory experiment. But before that, you need to know this time constant also. That's why I forgot it previous. So that's why now I mentioned. Okay, done. Now you need to keep the side heading as your transient response of time domain analysis of the series RC circuit with the DC excitation and start writing the derivation. Once it should be completed, you need to make the side heading as time constant of RC circuit. I will explain that. So before that, you need to complete the derivation of RC circuit. Once completed, inform me. Shall I erase the screen?
Yes, sir.
Yes, sir.
Okay. Now, what is the outcome we obtained? The voltage present across capacitor at the end of the derivation for RC circuit. Vc equal to Vc of t simply. Vc of t equal to what we obtained?
V into
V into
1 minus e power minus.
T by RC, right? Now
Yes,
you
sir.
need to keep the side heading as time constant represented by tau for RC circuit, for series RC circuit. Okay, right, note down. It is defined as the ratio, sorry, it is defined as the product of, it is defined as the product of resistance and capacitance of given, it is defined as the product of resistance and capacitance of given series RC circuit. So therefore in mathematically, how can we write tau equal to?
RC. RC.
R
Very,
into C.
very good. Very simple to remember. And the units are seconds.
Second.
So shall I rewrite the equation of your Vc of t like V into 1 minus e power minus t
T
by
by
tau. In the place of RC, I written tau. Okay, done.